All right. So in the previous class, we learned about port channeling, and we saw there are three ways of enabling port channeling. One is without using any protocol, and the other two dynamically brings up the port channel after negotiation. I told you the recommended way of doing it is with the protocol. So you may use PAGP or LACP, port aggregation protocol or link aggregation protocol. This is industry standard. Everyone uses this. This is Cisco standard. And in this, there are two modes, desirable, auto. In this, equivalent to desirable is active, passive. So you need to make one side to negotiate at least. So you cannot say two side act auto. Here also auto means they're not going to bring up the port channel. One side desirable, which will go and initiate the conversation, and when other side is agreeing, then the port channel comes up. Or both side desirable is also good. Both side negotiates, both side gets the confirmation before bringing the port channel up. But you can use this desirable only if you have both the switches Cisco. If one is Cisco and another one is a non-Cisco, then you got to have an option LACP. So either active on either side or one side active, another side passive is okay. And this is widely seen protocol to negotiate. On mode we don't use. Why on mode we don't use? Even when the other side is not configured, this side will say port channel up. And now what happens is this side A considers this two link as one virtual bundle, whereas on the other side that is not the way it considers. So you will see some abnormal behavior. There won't be communication. If you are 100% sure that you don't make mistake in bundling, then you can go and say on mode. Otherwise, depend on the protocol, rely on the protocol that is better, good for you. In here, let's say one interface is in the bundle on one side, but the other side is still not put in the bundle on the other switch. So this link will go to standby. Sorry, this link will be considered as member of bundle here. Whereas here, if you have one link in the bundle and the other side not in the bundle, this link will be standby because the protocol sends that the other side is not in the bundle. Only these two will become member of the bundle. All these things we saw live in the previous class. So if you don't get this today, you need to go back to the previous class video. Now what is for today is layer 3 ether channel. These are all layer 2. Layer 2 ether channel. What is layer 3 ether channel? On this virtual bundle interface, if you can give an IP address and ping between these two boxes over the bundle, then it is layer 3. All other things are same. Only one piece missing is you need to make this bundle, which you already learned how to bring it up, as a layer 3 bundle. By default, it is only layer 2 on the switches. The only missing piece to make it as layer 3 is one command no switch port. Switch port is the default on every port. Switch port, which is layer 2. Because it's a switch port. This command is available both on the physical link as well as the bundle. Physically it may be F0/10, F0/11, but these two member of this bundle. Now this bundle, by default it is layer 2, but you can make it as layer 3 by typing no switch port. Meaning I don't want layer 2, which means it will fall to layer, it will jump to layer 3. It will do layer 3 function. So what we are going to do is we are going to see how to configure this. As usual, you will be configuring port channel. At last you will add one command, no switch port. It's that easy. Let's see how to do it. But again, I want to mention something very important. What it is? You are trying to do layer 3 function on a route, on a switch. Usually, layer 3 functions are carried out on the router. So if you want a switch to behave as a router, a normal layer 2 switch cannot do this layer 3 port channel. You need a multi-layer switch. I repeat, to do layer 3 on a switch, the switch needs to be a multi-layer switch, meaning it needs to have the capability, feature support for both layer 2 and layer 3, both switching and routing. For the look, sometimes it may look similar, but inside the engines are different. So to do layer 3 port channel on a switch, we need to have a layer 3 supporting switch, which we call as multi-layer switch. In our simulator, we have both layer 2 switch as well as multi-layer switch. Let me show it. This 2960 is flat and small, and this is bulky and tall. This is a multi-layer switch. 3560, 3650. These are all multi-layer switch. For example, if I go to this switch and try to make it as a layer 3, interface Ethernet, interface fast Ethernet 0/1, no switch port. See, the command is not available, meaning it cannot be turned as a router because it's simply a layer 2 switch. Now let me take you to the other one. I'll take this one, 3560. I'll take two of them. See, the name itself is multi-layer. This can operate in a layer 2 level as well as layer 3 level. Advantage is you don't need to buy a router. In a small company, we can buy this. Why I'm saying small company? In a large company, in a big size company, making one device to do both the job, layer 2, layer 3, is too much to handle. So keep one box separate dedicated for layer 2, keep another box separate dedicated for layer 3. That is good. In a small house, you can do both the gardener's job, taking care of the garden, as well as the house job. But in a big bungalow, better you take care of your house. Don't focus on garden, because you won't be able to effectively take care of your house when you do both. Same way. Have a dedicated layer 3 device and a dedicated layer 2 device in a big environment. In a small network or enterprises, you can very well buy just one device instead of buying two devices. Instead of buying a router and a switch separately, you can buy one device. The space consumption will be less. Even to manage, you need to just log into that one device, not to multiple devices. Even the power consumption is going to be less. The cooling effect that you need to make in your data center is going to be less, because you are going to reduce the number of devices to half by buying this device. When you have 10 routers and 10 switch, then there are 20 devices. But when you buy a multi-layer switch, when you're deciding to buy a multi-layer switch instead of router and switches, then you buy only 10 devices instead of 20. So the CPU, sorry, the power consumption to maintain the cooling, the space consumption in the rack, the maintenance team's job will be less, because you don't need to jump to 20 device. You just got 10 device. Even the cabling, you don't need too many power sockets. What is this guy talking about power socket? If you think like that, you need to change your mind. Actually, this is where the problem really starts. You may have a very good knowledge on networking, but when you go to the real world, you will not be able to deploy all your knowledge immediately, because you will have simple problem like power problem, cable problem, all layer 1 problems, which you cannot do. You need one manual work guy, a beam boy. You need someone to go to the market, buy the power card, power spike, lot of simple works, manual works, not the technical works. Yeah, so when you reduce the number of devices to half, definitely the power cable is also going to be cut into half number. All right, now let's go to the story, main story. We are trying to form a ether channel between these two, but this time it's going to be a layer 3. I'm going to bundle 4 links in one bundle. Right now, only one link will come active, the other all 3 will go standby by STP, spanning tree protocol, which we have learned earlier. We have seen it. Even now you're going to see it. I'm waiting for some to turn green, some to turn. But if it is red for this long, which means the ports are shut down, let's bring the ports up. Oh, the device is not powered on. That's why. You see, there should be some. There should be some way to power it on. Do you see any power switch here? Power switch. No. This is management port. Okay, this is the power card. Power is plugged. If you want redundant power. Boom. Okay, it's loading. Let me also do to the other one. They have made too realistic, too much. Okay, it's retrieving the image. Okay, the other one is ready. Which one is ready? And now you're going to see only one going active, the all other going standby. You're going to quickly, shortly see this. Right now it is turning amber from red. STP is now using the BPDU. Okay, look at this. On the left hand side, it's a root switch, so no blocking on the root switch. All agree. Let's go and check that. First thing I want to name it hostname switch underscore one. Write to memory, show spanning tree. You see, this is the root switch. It is because of the small MAC address compared to the other one, and all are forwarding. Whereas this one, let me name it hostname switch 2, show spanning tree. You can see only one is forwarding, all others are blocking. It is because of the MAC address. The root switch MAC address is just 006, whereas the local switch is 005. Here, 00, and the third one is 5. This is third one is 0, which means this is smaller. Root switch MAC address is smaller, which is the second, this one, 006, smaller. That's why this is root switch. The other one is the designated switch. Only one is forwarding. We are going to bundle this. Before bundling, I'll go to that one port. You see, interface G1/0/1. So before typing this, you should know whether they are G or F or E, either by typing the show spanning tree, or you can know it by this place here. If you go here, you can see the names gig. It's not F fast Ethernet, it's gig Ethernet. Or you can type show IP interface brief. Show IP interface brief also will show you the names of the interface. All are gig Ethernet. Now, I'll just go to that interface G0/1/0/1. 1/0/1/. And now I'm trying to type no switch port. You see, it will accept. You see, it has accepted, which means this supports layer 3. I tried the same command on the layer 2 switch. You saw it was not accepting. Okay, so we are trying to do layer 3. Go to all the 4 ports interface range gig 1/0/1-4. No switch port. I made all those 4 ports as a routed port. Layer 3 port. Now I can put them in the bundle. You see? Again, interface range, channel, same command you already learned, CHANN, channel, group, any number. See, there it was supporting only 1 to 6, but they support up to 1 to 48. You can have, you can have 48 bundles like this. I'm just going to have only one bundle now. Sorry, mode. Depending on what protocol you're going to use, if I'm using LACP, then I have to say active or passive. I'm going to say active. All right. Now the port channel won't come up. Show ether channel. You see, the capital I means it's in a standalone. Why? Because LSCP went and negotiated the other end of the wire. Other end of the wire is not ready yet. We didn't configure. We just configure only on switch 2. So the negotiation failed. That's why you see the capital D is down. And here it is not S. In the early class, we saw capital S, which was layer 2. Now you see it is R, layer 3. Layer 3. Because I said what? No switch port in all this interface. Above here, I have said no switch port. That is why. It's a layer 3 ether channel now. In layer 3 ether channel, you see show IP interface brief. It's not having an IP address. And it is down because the other side is not yet configured. Let's first go to the other side, configure, and then come back and give IP address. I'm on the switch 1. Show ether channel here. You don't see anything configured yet. It's not configured yet. So I'll go now to interface range gig 1/0/1-4 channel group 1 mode. That side I said active, this side I can say passive. Now I'm expecting port channel to come up. After negotiation, it will come up. One more thing is I'm going to say no switch port. You see, immediately the port channel interface has come up. Now you go back to the second switch. Earlier when I checked, this was down. Now I'm expecting up, and this was D. I'm expecting U. What is U? In use. And then I'm expecting here the capital P instead of I. What does it mean? It's active in port channel. Let us check that. Show interface brief first. You see it is up now because the other side is up. Negotiation was successful. Second thing is, you see it is capital U and all the interfaces are P. Also in switch 1, same command, show ether channel summary. I can see all are P. But you see the bracket, it is SU. Why SU? We expect R. Why it is S? Because I said passive. I said no shutdown, but I did not say no switch port. Accidentally I said no shutdown. That's wrong. I was actually trying to say no switch port. I'll shut down this port channel, interface port channel 1, shut down, and then I'll go back to the group of interface, and then I'll say no switch port. Okay, shut down this also, and say no switch port. Come on. Why it is? Command rejected either layer 2 port. Yeah, problem is already layer 2 came up, so it is showing this error. But after some time it will accept. Or I need to restart the device. It's conflicting with what I configured earlier. Okay, it is down now. I am happy that it is down, but I want to completely remove no interface port channel 1. Okay, now I'll go back to the group of interface and say no switch port. Accepted. And now I'll say the channel group command. What is that command? Channel group 1 mode passive. And say no shutdown. Now you can see port channel also coming up, and it will be layer 3. Show ether channel summary. You can see it's capital R now. So making it as layer 3 is no switch port on all the physical ports. And the bundle will become automatically layer 3. Now you see show spanning tree should not show any output because we don't have layer 2 here. We got layer 3. But show IP route also not coming. What is this? It is not showing layer 3 table. Routing table is layer 3 table. The reason is you made the interface as layer 3, but you did not enable the layer 3 feature globally. This is a switch. By default, only layer 2 is on. So globally, I need to say, hey, buddy, IP routing, support IP routing. After you say this, if you go back and check the routing table, you see something now. Earlier, this was not shown. Let me go up and show you. You see, just something 2 lines you saw. But now you see, it's ready to support routing protocols like EIGRP, OSPF, RAPE, BGP, BGP, ISIS, all of them. Static group. So let me also say the same command on the other switch. IP routing. This enables routing on the router globally. Okay, check the routing table now. Show IP route. Okay, the routing table is empty, but the routing table is formed, but nothing inside. The reason is we have not given any IP address. Now, where will you give IP address? Will you give to this physical interfaces? No. We have combined all these interfaces as one bundle. So we have to give it to the bundle, not to the physical interface. Why this is red? Shortly it will turn green. Wait for it. Some negotiation, some conversation, some discussion is going on. Because I just enabled routing, So it's turning to be a full-fledged router. As well as switch. It's both the router and the switch. Only these 4 ports are a router. What about the other ports? They are switch ports. So you can have both switching capability as well as routing capability at the same time. That's why we call this as multi-layer switch. Okay, let's go quickly and check the status. Show ether channel summary. Okay, I can see here the good news is all are the member of port channel PPP and layer 3 in use. Even on the other side, I don't know why this will go dance in the middle and then come up. Show ether channel summary. Okay, so I can see the port channel is up, but why the simulator is showing red? No reason. Show IP interface brief. All are up. Anyway, ignore that simulator. Now let's go and give IP address to have something in the routing table. What I'm trying to do is, just for your reference, I'm going to write here to the bundle. I'm going to give on the PO1 interface 0.1/8. And here in PO1 interface 10.0.0.2/8. Okay. Now let's go assign the IP addresses. Interface port channel 1 IP space address 10.0.0.1. You cannot put slash, so you need to write the mask /8. This is how we write. And now if you go check the routing table, show IP route, you will see a route. You see, 10 network is connected via port channel 1. You know what is port channel 1? It's a bundle with 4 physical interface. And for that 4 interface, this is the IP address given. Let's go and check show IP interface brief. Look at this. For this 4 physical interface, this is one representative. So when someone is trying to ping this address, they will be coming via all these 4 links. It depends on the load sharing. I showed you the algorithm to load share. Okay, let's go to the other side and configure IP address. 10.0.0.2. Now, check the routing table. You got the route. Now, if you try pinging before that, show ARP. See, I don't have anything in the ARP table. But when you try pinging, it will resolve. 10.0.0.1 is the IP address on the other switch. You see, it's resolving. That's why you are losing first packet. You see, I lost the first packet. Only 80% is successful. It is because to learn the MAC address of 10.0.0.1, which is switch 1, it took some time. That's the time where the ping failed because it did not respond on time. ARP took some time to give the MAC address for the ICMP to send the echo packets. But now if you ping after learning the MAC address, now if you ping all 100%, you will get success rate is 100%. This is what we call as layer 3 port channel, assigning IP address to the bundle. Now I can have a routing protocol like EIGRP, OSPF, or report, which we'll be learning in our future. We have not got into layer 3, which is very interesting yet to come. Okay, so here we see that we are able to ping. Layer 3 port channel is done. Ignore this amber sign. It should not be amber like this. It's a simulator. It's pinging very well, okay? It should not be amber like that. And what we can do is we can just turn, I'm saving it and I am unplugging this. I offed it. Good. And I'm going to on it again. Okay, let's on it again. Power supply A remote, power supply V remote. So realistic now, you see. Okay, the port channel is up because I saved it. Now I'm expecting both side both side green, just to show that this is the problem with this simulator. I have done this. So what will be our next topic, Our next topic is inter-VLAN routing. We learn the VLANs. Members of same VLAN can communicate, but members from one VLAN cannot communicate to other VLAN. But what if I want them to communicate? If you want them to communicate 2 ways, either you need to buy a router for routing between the VLANs, or you need to use this type of multi-layer switch. If you have switch, it will have all the VLANs, and you can also make the switch to do intercommunication between the VLANs. That is what our next topic is going to be. Inter-VLAN routing. The inter-VLAN routing can be done like this. You see, you can have a router and a layer 2 switch, and you can have some members in VLAN 10, some in VLAN 20, And if you want to make this VLAN 10 member, this computer, to talk to other computer which is in VLAN 20, it is not possible until you have a connection to a router. So once you connect to a router, member of this VLAN 10 can talk to VLAN 20. VLAN 10 member. This is going to be VLAN 20 member. The IP address will be 20.0.0.1. This IP address will be 10.0.0.1. By default, they cannot talk each other because they are in two different broadcast domain. Each VLAN is one broadcast domain. VLAN 10 is one broadcast domain. Another 20 is in another broadcast domain. Another reason is they are in two different network. To bridge between the broadcast domain, to make communication between two different network, you need a router. We call this as a router on a stick method. Or what? Router on a stick. STICK, stick. Kuchi. Kuchi mail ulla router. Okay, whatever. Router on a stick. This method is called router on a stick method. This has got some drawbacks. So what people do is, instead of going for a router on a stick, they buy a layer 3 device. They buy a layer 3 switch, a multi-layer switch, or layer 3 switch, a multi-layer switch, which can have VLAN 10 like a switch, VLAN 20 like a switch, which can also do routing between these two VLANs and two networks. So you don't need another router now. We are going to do both, router on a stick as well as multi-layer switch routing between VLANs in our next class. Oh, for this time both did not come green. Again, I tell you, it's a simulator. It's a simulator issue. You need not to worry about it. As long as they ping each other, that is enough. Let us ping show IP route. I see the route 10.0.0.2, which is the second switch IP. I'm able to ping. Okay. So layer 3 ether channel is over. And what we are going to see tomorrow is an inter-VLAN routing, both methods. One router on a stick, another one using multi-layer switch. With that, we'll give a pass to the switching. We'll come later to the switching. We'll get into routing from Monday. So tomorrow it is going to be multi-layer switch, router on a inter-VLAN routing, and router on a stick, inter-VLAN routing. On Friday it is going to be SPAN, switch port analyzer, SPAN, RSPAN, remote switch port analyzer. With that, we'll give a pass. Actually, main topics of switching getting over by this Friday. And on Monday, we're going to start with routing. Any question on today's class? Right. If